Hi, Carlos.
Hi, how are you?
Good, and you?
I'm a bit early, maybe.
Hi, Lily.
Hello. Hey, Carlos. Hey, Jen.
Hello again.
Have the two of you met Sebastian before?
Well, only in the recorded video from YouTube, I think.
Yes, that's right. You said you were looking for the Google Analytics section
Yeah.
that we published. Yeah,
Yeah, so yeah, I have met you, but you haven't met me. Hello.
that's right. Nice to meet you.
Nice to meet you.
So Yevgeny is not coming today. It's very late for him, but I think,
so.
yeah, he said he will come next time and wants to talk to everybody about the transform functions and the new code.
Cool. Exciting. Exciting, yeah.
And also from our end, I think Joe is going to come as well. I'll ping him though.
Have you seen more talks from ATO, Lily, or anyone else?
I watched a few when it happened, but there were several that I wanted to go to but couldn't. You know, either they were double or triple scheduled, or I just couldn't make it. What about you?
I haven't, but I want to catch up some on YouTube when they appear.
Yeah, they said that they were going to try and put all of the videos up pretty soon, but there's a ton of videos, so I bet it'll take them at least a little while to get through them.
Yep. ATO is a milk brand in Spain. Kept making me laugh, the FD ATO, bit link and ATO this, ATO that.
That's great.
Yeah.
Yeah, it seemed a little bit like FOSDEM in the sense that there were so many talks.
Yeah. And this weekend is Python Texas.
I don't know that.
Searched for Frictionless and Lily, and I was disappointed not to see anything.
Yeah, missed that one somehow.
Yeah, it's quite interesting. They have a few general programming things instead of very specific. I plan to attend. It's on the weekend. It's easier.
Oh, cool.
Anyway, it will be my evenings actually.
Sure.
Huh. Have you seen it? I mean, have you found it?
I found it now. Yeah.
Okay.
Googling Python Texas doesn't get a whole lot of good coding results.
That's why. Yeah, that's.
It looks like you have a lot of problems with Pythons there.
Well, pytexas.org.
Yeah, I got it now. Cool. Yeah, thanks for letting me know about that. I'll look into it.
Yeah, no, they had a few things that were quite interesting. Let's find which one now. It's even a bit of data science. I don't know. There were a few interesting things, I thought.
Oh, Al Swiegert's talking. That's
That's amazing mutable tuple. It's
Yeah.
in front of here. Who is him?
he wrote a book about learning Python. That's what I used to learn Python when I was in grad school. So he's like, I like him because of that.
Yeah.
It's called Automate the Boring Stuff if you want to look for it.
Yeah, I see. Interesting.
Okay. Should we wait a few more minutes? See if it's more than us four?
So just to ask I'm ask Sebastian just to check. Well, so let's just pause recording for a moment, Sebastian, on the record. Just
Okay, so for those who are missing the link, here is the meeting doc in the chat. And so we had an agenda for today with Oleg and Kate, but for some reason they confirmed the meeting, but they were not assisting. They are not here yet. So Oleg is trying to join. Okay.
I was having issues with the Zoom ID. I don't know why, but
Hi, everyone.
Hey,
Oleg.
Hey, Oleg.
Hey, Oleg.
Can't stay very long, but wanted to say hello. Can't start my video for some reason. Try rebooting Zoom. Been a lot of Zooms today. Be right back.
Okay.
Okay. Let's get, guys, do you want to share your screen with the agenda, Sebastian?
Yes, just a second.
I'm also
Okay, can you see my screen?
yeah.
Okay, Keith is trying to join. Yes, for some reason, I think Zoom, like you said earlier today, I think we need to set this up with a password.
Yes,
because
I'm getting an invalid ID. People should be in the waiting room, but I'm definitely getting, like when I was clicking on it earlier, I was having issues when I clicked on the link, and it makes me concerned that the link doesn't work so well. I don't know why.
Yeah, I'm just joining now. There's a link to a Google Hangout, and me and one other person ended up there. And then the Zoom link wasn't working at the time. I don't know if it's changed or just hadn't started yet. But I eventually went to Discord and found the link there.
I got it. Thanks, Keith. And we will bear this in mind as a breakdown. I did mention that, Sebastian. So let's not have both. Let's just not have both a Google Hangout.
Okay.
Well, greetings, everyone.
Hi there. Okay, so I'll share again in the chat for those who missed the link. And there's the link to the meeting doc. And in there we have our agenda for today.
Okay, let's get started. people, I mean, some people I think here are kind of familiar. I know that some people aren't, but like I haven't got to meet you, Keith, before, so it'd be great to meet you. My name's, I can introduce myself. I'm Rufus. I'm the founder of Open Knowledge Foundation, also one of the founders of Datopian. And I'm also started the Frictionless project. And so I'm very passionate about simple tools, simple systems, and data, and wrangling data, using data to get insight. We're just using data for all kinds of purposes. Yeah, so that's me. Really great to see you on the call.
Yeah, thanks for having me. I can introduce myself if you all like, or I'm
That would
also
be
happy
great.
to. So yeah, my name's Keith. Good morning, good afternoon, or good evening to you all. So I'm currently a postdoc at NIH in the National Cancer Institute. And I do kind of research in bioinformatics and genomics. So my undergrad degree was originally in bioinformatics, like years back, finished in 2007, December. And then I worked for a little while as a contractor at the NASA Goddard Space Flight Center, also kind of working in science data, but there in the solar physics department, and worked in kind of data analysis and visualization. So very different, but still very much tied to science. And was already thinking about a lot of the issues that, relate to this kind of handling of data and normalization of data from different sources and provenance. And then eventually I worked there for about 4.5 years and went back for my PhD at the University of Maryland, also in bioinformatics. And kind of main research was on network analysis of host pathogen systems. And again, using kind of computational pipelines and bringing together different types of data and struggling against that for a long time. And then before finally ending up at NIH, where I've been for the past 2.5 years or so now. But yeah, I mean, this is something that I'm also generally quite interested in. And I'll elaborate if we have time a little bit later on kind of my motivation for trying to participate in the effort and, see how data package can be used. But I think it's definitely kind of a lack of standards, and the difficulty in integrating different data sources is a huge problem in biology and bioinformatics. And I think a lot of good could be done by making some progress on those fronts. So yeah, thank you for having me.
Thanks. That's just great. We love to hear more. And also, just for a moment, Sebastian, it's great. Would we just stop sharing so we get to see it? I think because it takes over the screen a bit just for the moment. We'll come back to the agenda in a moment. That would be amazing. Thank you. Welcome. I don't know if anyone else, people want to briefly, maybe some of those who are more frequently here, just whistle stop introductions. Yeah, maybe. Yeah, who would like to go next?
I'll go briefly. Most of you know me, but Keith, I don't think we've been actually introduced yet. I think I've talked to you on Discord some, but I'm Lily.
I appreciate your feedback and answering questions.
Yeah, of course. It's really helpful to have users come to the Discord and ask us questions and give us feedback. So that's great. So I'm the product manager for the reproducible research part of Frictionless Data, and I'm at the Open Knowledge Foundation. And yeah, you'll see me in the Discord a lot. And so we're working specifically with researchers. So your use cases are, very well in line with what we're working on. Yeah, and if you have more questions, ask. If you are interested in doing more of like a case study, that's something that we are always interested in. So yeah, just let me know if you want to talk more about that.
Okay, great. Thank you.
Anybody else want to do a brief intro?
I can do a very brief intro. Oh. I'll do a very brief intro. I'm Joe. I'm the project manager of Frictionless Data at Open Knowledge Foundation. So I've been being the project manager for probably about 5 years now. And I haven't been to one of these for a while, so I thought I would come and say hello.
Hi. Well, some of you know me, and I just remembered that we had some mails with Joe Barrett now. For the last year and a bit, I'm working for the Swiss Polar Institute. And then we have a very clear use case for Frictionless, that we get data from scientists and we publish this data. And in the Institute, we document the data for the last half a year, more or less, using the Frictionless schemas. And now, as a very practical use case, we pass this data, the data package, to another institution that they map, or they put this data on a map and graphs and plots. So instead of having a textual description, we just use all the infrastructure from Frictionless. And on the top of this, for the last 3 months, I got very lucky and I got one of the tool funds from Frictionless. So I'm doing some more work hands-on on Frictionless tools and doing some new systems, or one new small system.
I'm Jen, and I work with Carlos at the Swiss Polar Institute as well. But I work more with the researchers. So I'm a research data manager. So I help the scientists to wrangle their data and get it in some kind of form to make it publishable. We publish the data through Zenodo, which is a platform where you can freely publish data sets up to a certain size, and that's run by CERN to make them publicly available to whoever wants to use them there. So I deal with more the asking the scientists for metadata, or to populate metadata, and to get the data sets into a decent format. And Frictionless is really helping us make sure that we try and get the data into a nice format using the table schemas. So, yeah.
Okay, Oleg, have you got to introduce yourself?
I don't think so. I was struggling with my video. Hey, everyone. So I'm Oleg. I'm based in Bern, Switzerland. And I spent my day also working with some scientists on a research group on collecting some research network data and migrating it, and having to work out some data flows around how they're doing collaboration around it. And I run some hackathons and events in the open source community. We've got tomorrow a big event for the open source kind of digital sustainability topic. And I'm also working on geospatial projects with a group in Zurich called CVD. And we're working on really kind of frictionless data libraries as the basis of our little startup project. So I'm quite excited to be here as well. Thanks for organizing.
Great. Sebastian, have you got to introduce yourself?
Yes, I can do that. I'm currently working at Datopian. I'm working part-time on Frictionless. And usually I work on the Python side on internal projects, but yeah, I hope to be more involved in the community this month or next month. But up to now, I'm getting up to speed. I'm not involved directly in the projects, but I'm happy to be there.
So generally, we open it to a bit of Lily. Do you have something you'd like to? Yeah, go ahead. We open it to kind of Q&A. Great.
I was just going to do what you were doing, Rufus. Please go ahead.
I'm also trying to get hold of Yasso, but I don't know. She said she'd be on the call, but I haven't seen it yet. So anyway, that's no problem. It's the new. Okay. Yeah, I mean, Keith, I would love to hear maybe just at the beginning from you. You were kind of saying you'd like to share a bit more about what you got up to and your thoughts and opinions and questions. That would be really great.
Sure. I put together a few slides. I can go through those, but then if it's too long, I can just give you a short summary. But I mean, it's only 3 or 4 of them. Is it okay if I share a screen?
Go ahead.
Let's see. I think you have to enable it for me.
I think so. I suspected that was gonna.
Yes, that should be on.
Okay, seems to be working now. Let's do desktop. Don't need to share sound. All right, can you all see presentation?
Yes.
Yes.
Great. So before I even start, let me just preface this with the caveat that this is all kind of a recent effort and really something, I mean, I've been aware of data package maybe for the past year or so and frictionless later on. But it's really only in the past couple months where I've started to flesh out these ideas more thoroughly and actually try to use them in useful applications. So this is kind of my perspective on that experience and kind of thoughts on going forward and how this could potentially be useful in biology and genomics. All right, so just to give you a little bit of background, the challenge, or there are some challenges to kind of working with bioinformatics data and doing analysis at scale. So one of the big goals of biology and kind of bioinformatics is to be able to develop systems models of organisms, of cells, of tissues, and so on. So far, the models generally fall short of what people kind of expected we would be able to do at this point in time. Part of this is probably just due to the fact that we have incomplete data. We have all kinds of biological assays, to collect information on cellular states. But in all likelihood, there's a lot of things going on that we're just not capturing because we're not there yet. We don't understand it. But another major issue is that the ability to kind of integrate data is severely lacking. So even in the kind of largest scale studies that have been done collecting biological data, so things like the TCGA, which was kind of a pan-cancer multi-institute experiment that was performed over a decade or something. Like that has thousands of samples or observations essentially of different kind of tumor data sets or tumor assays. But this is still way too small to really start to even build these kinds of models that we want to do. The problem is basically that, for a typical human cell, you have something like 20,000 protein coding genes. And if you include other non-coding genes, it goes up to, 60,000. So you can imagine that trying to model a system with 60,000 variables and only 1,000 observations is not going to work out so well. So one possible solution to get around this is to try to think about better ways to integrate data from different sources, because there are, tens or hundreds of thousands, probably even millions at this point in time of data sets and samples collected of, human and other organisms. But the ecosystem out there right now is kind of a mess. So data, depending on where you get it from or who ran the experiment, it could be processed differently, include different types of metadata. Even the efforts like GEO, which is from NIH and NCBI, it's a big kind of repository of gene expression data, which is one of the kind of important types of genomics data. Even their data is kind of a mess. Like they encourage users or require users to submit metadata, but there's no validation done on it. The quality of the metadata is hit or miss. And here's just like one example of a data set where someone, these are kind of the metadata fields captured. And one of the interesting things that you'd like to know about the disease stage is actually encoded in the title of the sample. So you have to parse this out manually, which is a pain. So yeah, those efforts aren't there yet either. And a lot of these, like GEO doesn't do anything to normalize the metadata. So it makes it really challenging to do this at scale. So one of the things I've done over the past couple of years in the postdoc is trying to do this kind of data integration for a relatively small set of experiments, 25 all from one type of cancer. And it basically just required a lot of manual processing of metadata and kind of finessing to get the data to work together. And in the end, it's really useful and we're able to learn a lot from it. But that process should be much simpler and could be a lot simpler. So that's kind of the motivation. All right, so what my approach then and how I think data package could be useful and frictionless is to basically create a repository of actually clean bioinformatics data. So a lot of these existing repositories, try to clean up the data and they do help in some ways, but they still, like I said, they're often missing this kind of normalization of fields and things like that that is essential to doing anything automated at scale. So what I thought I'd do is create pipelines to build on top of these existing resources and try to go one step further and really get things to a very consistent format where it becomes much more trivial to then start to integrate data. So I don't want to recreate the wheel. A lot of work has already been done, and it's also computationally intensive to work with some of the raw data. So my thought instead is to build on top of some existing semi-clean data products and resources. The focus then would be on the downstream data products. So instead of working with the raw sequence data, which is gigabytes or terabytes, I'd work with the kind of count tables and matrices that have been generated on top of those. And kind of one of my thoughts in how I want to approach this personally and how I think could be useful is basically prioritize consistency and transparency over perfection. So if someone is actually a scientist working in the field and they're an expert on some type of data, then they might have a very specific way they would want to process the data, and they want to kind of go over it with a fine comb. And that's perfectly fine, but it's not practical to do that for a large number of data sets and for a large kind of variety of different types of data. And so my belief is that, instead of trying to do things perfectly and painstakingly every time, is let's try to do it good enough. So basically make some reasonable decisions about how data could be kind of normalized, cleaned up, filtered, and how to kind of prepare the metadata. And then just document exactly what was done and put the code online along with it. So people, if they're really interested in understanding how the data has been transformed, they can go back and see that. But instead, I'd rather just, kind of make some of these decisions knowing that, there's some kind of trade-offs along the way. But the benefit would be that we could then get the data much more quickly into a useful state and still, I believe, preserve most of the important signal and information. Okay. And yeah, like I said, a big part of this will just be building on top of other efforts that already kind of get us part of the way there. I also think that ontologies could be useful to help ensure kind of precision in terminology in the metadata. And so there are a few, there's a lot of different ones used in biology in general, but these are a few I think are particularly useful for kind of bioinformatics and data analysis pipelines and so on. And I'm also interested in kind of capturing data provenance information. So I'll give you an example in a moment of how I'm doing this already and how I'm thinking about doing it in the long run. But basically, if you have some data that's in a data package, and then I perform some analysis on it in a pipeline and generate a new derived data set, it would be useful and not all that difficult to capture the information about the kind of original source data and what steps were taken in the derived data set metadata. And ultimately you could imagine that if you have some rawish or let's say clean data that starts and then you process it in one way and then perform analysis, it wouldn't be that hard then have a whole lineage captured in the metadata, so someone could clearly see what has been done. Yep, and ontologies are also useful here because even things like data transformations and analyses can sometimes be captured in these ontologies. Okay, so I won't go through all this. This is probably more than you need to know, but this is the basic idea of how I'm approaching it so far. So we have the raw data sources, and what I'm calling right now just kind of data recipes. And this is basically my manual steps where I'm taking data from sources, looking at what needs to be done to get it in a kind of semi-clean state, and kind of doing a light level of processing there. And for the next step is I have a pipeline called Data Packager, which I can show you. It's written right now in SnakeMake, which is a computational kind of pipeline framework commonly used in bioinformatics. It's kind of modeled after Makefile and allows you to mix R, Python, and other languages if you want to. And it's just a kind of nice, quick way to build up pipelines. But yeah, so I have a data packaging pipeline that basically takes these clean data, uses some YAML metadata that I describe each of the source data sets with, and then generates actual data packages. And so that becomes a separate repository. And then from there, I can start to feed these into bioinformatics pipelines that I've developed to do different useful things. And each what I've done, so some of these I already had in the past to do these kinds of analyses. But what I've done in the past few weeks, in the past month, is to start to basically modify the existing pipelines I have to both ingest and generate data packages, and also to start to capture some of this provenance information. And I mean, the long-term goal is, yeah, to just have data that's much more consistent and could be easily integrated. A lot of what my research interests in the long run, and where I think we could benefit a lot from, are, as I mentioned before, integrating large numbers of data sets. But there's also kind of other useful things, like by using data package, it becomes much simpler to write kind of generalized data visualization and data exploration tools. And I think that could be really useful. Okay, so
can I ask some comments? So do you know about the, there's a kind of view, there's a very basic kind of like spec for kind of adding views to data sets that isn't like trying to invent the wheel, but it's just, to obviously there's stuff like, I'm having a complete mind blank suddenly. There's a spec, a JSON spec. I've just forgotten its name. Oh my god.
Not JSON scheme. I mean, that's
no. For describing visualizations. For describing visualization.
Okay.
It's called Vega. But there's also this
yeah, I have seen that. That's like
right. But so we're not trying to,
right?
Yeah, well, we're not trying to replace it. But what you need is some kind of binding between the data set and whatever you need something that just says in your data package, hey, I've got this visualization and it uses the Vega grammar as a way of describing the visualization, so this tool can plug in, but you need some bridge. That's a really great idea. Exactly. I mean, this is mused by it. Sorry. Let's come to your thoughts and next steps kind of question.
Okay, yeah. No, that's, I appreciate it. That's so I've come across that before, but I haven't actually looked into it recently or thought about it in this kind of context.
Yeah, and there's also stuff in Frictionless to do the views work, which is, what I mean is that there's nothing just to say how to specify in a data package that this like, oh, I want a section which is describing visualizations, and it uses, let's say, Vega to describe the visualization. But it's just like that small bit of glue is done in the Frictionless specs. Anyway, onwards.
Cool.
This is
I'll
brilliant.
have to look into that. Thank you. Okay, oops, it doesn't matter. That's not animated, sorry. Let's try that again. All right, all at once. So overall, like the experience has been quite positive, I would say. Like, I mean, all these kind of pipelines or the adaptations I was talking about just now, I was able to do in the matter of, weeks or days, after an afternoon sometimes, to adapt things. I can show you real quick. This is all local, but I mean, so this is just a small example of some of the data packages that I'm generating for different public and kind of personal research projects. And the pipeline to do that is here. But this is where, so I mentioned how the very first step to packaging things, I have some kind of metadata that describe the different data sources.
Yeah.
And so here's just one example of that. So this is PharmacoGX is a resource that attempts to bring together different kind of drug screen data sets. And so some of these efforts, like CCLE is another one that's like a multi-year or multi-institution, like, 5-10 year project and stuff. So they're going part of the way to normalizing some of these data sets and making it easier to work with. And I'm just basically going one step further and building on top of them. But then by defining this kind of basic metadata and doing this consistently with other data sets, then you can imagine how it's not that hard to go from this to a data package.
Yeah.
So yeah, it's worked out really well overall, and I'm quite happy. So one thing is genomics data tends to differ from other kind of data that I think is typically probably targeted or thought of for the frictionless specs. So a lot of genomics data is numeric matrix. It's kind of assessments of some gene in some patient or cell line. And so you might, typically these would be something like 60,000 rows and between 10 and 1,000 columns. And that's the other thing is, so the data is often, it's inverted from how most other fields and kind of people work with data. So usually one would have the observations as the rows and your variables or features in the columns. Because we have this kind of problem, big P and small n, where we have many more variables, just historically biologists tend to flip this. And it kind of makes sense, right? Like if you had 60,000 columns in 10 rows, it would be a pain to work in Excel or Vim or whatever you're working in. But that also just means that, yeah, like what you think of as fields are actually our observations and vice versa. So this could be something that one might consider incorporating into the specs in the future, some way to indicate that orientation, if it's important to differentiate, fields from observations.
Yeah, Keith, we've had that discussion before with some geneticists as well. And I can't remember if I sent you that link, but
you did.
Right? Yeah. Oh, okay. I was going to say right now the plan is to not change it, but I think it's important to hear that it would be helpful for you again, because that is something that maybe we could consider adding in the future.
I mean, to be honest, I'm not even sure if it is essential at this point. Like I haven't hit any roadblocks due to this. And just, I think just having a standard that is well thought out and I can follow for kind of describing the data and, generating data products is already most of the challenge, I think, or a big part of the problem. Whether if there's like a large number of fields described in the data package metadata because of how many observations there are or whatever, that's not the end of the world. And, I think if it's processed automated anyway, it won't be a big challenge. If we ultimately, I think it could be interesting or worthwhile to maybe consider, genomics or bioinformatics specific specs, in which case perhaps this could be something considered there. But that's ultimately up to you guys too, and what your desired scope is and how you think about this kind of specialization of different data types. Like I know you have some now for financial data and I think a couple other data types. So perhaps that could be one route to go for dealing with genomics data.
Mm-hmm. Yeah.
So this is kind of a side note or observation, but what I've been doing and I think is kind of interesting and other people might consider is it's not that hard if you're already processing data to compute some summary statistics. So just, mean, median, range, kurtosis, whatever along. Yeah, exactly. Embed that in the metadata. And then you could imagine basically very quickly reading in the metadata and then generating useful plots and summaries without having to do any computation on the fly.
Yes.
So something, yeah. And I mean, you could also imagine even embedding like base 64 encoded plots if you wanted to, although I'm not sure if that's the best use, just something else I've considered. Long term, yeah, I think it could be useful or interesting to at least explore developing some biology specific specs to deal with these kind of quirks of how the data are formatted and whatnot. Something I've also been thinking about is how to kind of hierarchically define or organize the data models, because, there is generally genomics data all tends to follow this convention, but then there are different types depending on the assay. So one could imagine defining one kind of master spec and then either having subspecs for different data types or possibly just defining specific terminology to use in the metadata to delineate which is which. So the next step for me personally, so most of this I've been doing kind of on my own at this point, just to get a sense for how feasible it is in the long run. And after I've done just a little more work on the kind of prototype pipelines and maybe have the chance to put together a web interface to actually explore the results, I'll probably, my plan rather is to reach out to some other people I've worked with over the years in the kind of bioinformatics community and get feedback from them and kind of see what things are maybe problems that I haven't thought of already and how they think we can move things forward. And then longer term, I'll have to figure out how to pay for this. So right now, like, it's free and easy to write code and share that. And that's already probably could be helpful for some. But it'd be really useful to be able to have an actual data repository where people could go and click a link to download a data package for data X, Y, and Z. But that's something I'll have to, again, find a way to fund. And
you know that do you know that Data Hub IO exists, which is the...
I have seen it. I haven't. So is that hosted and funded by you all?
Yeah, that's hosted and funded by Datopia at present. I can go a little bit, you're aware of it. We can go on it in more deep depth, but that's a great, just to check.
Yeah. So, I mean, that was one of the inspirations for me moving forward on this project. Like, I liked how clean and nice the interface was, and I could see how lacking that is in bioinformatics and how useful it would be if we had something like that. So long term, that's kind of the direction I wanted to go in anyway, but I hadn't really considered that yet. So that's maybe something worth looking into more seriously. Thank you.
Keith, I had a few other thoughts while you were talking. One is that I'm gonna connect you with Phil, who is one of our pilots right now, Phil Rocasera at Oxford, who is doing some similar work to this.
Okay, great.
Really working on like profiles for different areas of biology, and he works on the stato ontology, the statistics ontology as well.
Oh.
And so I think there will be a lot of overlap, and that it would just be great for y'all to talk. So I'm gonna.
No, that sounds fantastic.
Cool. And then the other thing was, we've had some groups post their data as data packages onto Zenodo before. So if, that's just not another option.
Okay, yeah. Let me see. Oh no. Oh, wait, stop share. Sorry. I have seen Zenodo, and yeah, that's something else I hadn't considered, but is definitely worth exploring. Thanks for the suggestions.
Thanks for your presentation. That was awesome.
Yeah, no, I appreciate it. And if people think of other feedback, down the road, feel free to reach out either on Discord or over email. And thanks for having me in the meeting.
One quick thing, just because we were talking about Zenodo and Data Hub IO, I've never seen, and maybe it would be possible for you. So sorry, Zenodo has an API where you could push data and pull data, and
yeah,
I've never seen anything. Well, I see the point of having a bioinformatics or some discipline repository, but I don't know if you could use Zenodo or an existing one as a backend storage.
Yeah.
To be honest,
for saving.
I mean, that sounds like a great idea. So, I mean, that's one of the biggest challenges, practically speaking, that I've been thinking about how to deal with right now is just like, I'm doing a lot of this on my home computer, and I have access to a cluster and things like that at NIH. But it's fine for the scale that I'm working at now. But obviously, if I want to scale this up and process lots and lots of data and make it available to others, then I can't just do it on my computer sitting in my bedroom.
There's two parts to the story, by the way. Just we're kind of getting a little bit off topic. So one could use Zenodo or lots of it. I mean, one is you had two questions. One is, yes, Data Hub, but it depends on where it has an API. Yeah, you can basically just push a data package to an API endpoint and it will work. Like, so there's a full-on API, like automatable API. In fact, kind of fundamentally, there isn't a UI at the moment on Data Hub. We didn't build one. I did not build yet. I worked on it, and in fact, there will be one very soon. But when I built Data Hub 3 years ago, which was like my initial attempt, and I'm about to release the third version of Data Hub, if you like, which will be everything has to be built 3 times to be good. But it's pretty good already. But in the sense there's no UI, there's only an API. It was kind of built for kind of power data users. So you literally could push data. There was also some pretty fancy things in it, by the way. There was equivalent of like GitHub Actions, like files. Like you could kind of commit a GitHub repository with this like .datahub kind of folder, which would do transformations on the server. That was the dream. Like you kind of could push the data and then push a transformations file, like a make file that would then run on the server and would do stuff to the data and things. It was quite, that's not really very well documented. There's a blog post about it. And it comes to the second point. So there is an API to it. Whether, and but there's a Zenodo, it's awesome too, or whatever, you know, I'll come a little bit. There was also an idea, I'm glad you like the UI, because I personally designed that UI a bit. The read UI, like the vision, the ability.
Yeah, no, it's quite nice.
It was very simple. But the thing that you're also asking about is the ability to run compute, and particularly data pipelines on the server. It's kind of or on some cluster somewhere. They don't have to be. They don't have to be in the storage location, but you probably want to run some of the stuff not on your local machine always. You know, like. So just to give you a very real example. Yeah. Go ahead.
I was just gonna say, to be honest, that's actually, I would say, less of a concern at this point. So I mentioned earlier how one of my kind of design decisions was to skip a lot of the early data processing steps that are computationally expensive and basically build on top of what's already out there.
Yes.
And so actually, even as I'm kind of downloading, you know, large numbers of data sets, it's not really that much computational power needed. And I have, like, at home a 32 core 128 gig memory machine, and that can do pretty much everything I need to and a lot more at the time. And yes, I mean, in the long run, computational things will become an issue, but
I mean, I don't want to go too long. So your restriction is at the moment storage space. That's what your problem is. You're worried that at some point
it's more like a network bandwidth and things like that. Like, you know, a home network's not really the best way to serve data.
I got that. I mean, I have it as an issue right now, which is we fund data. We basically, other than Oleg on this call, who I think is one of the few subscribers, we haven't really pushed the subscription option on DataHub.io. We have very few subscribers, and we pay about, so now, like, it's getting on for $1,000 in bandwidth fees of like thousands of dollars, and we don't have big data sets on there even. You know, but anyway, I got a couple of questions, but other people have questions, like Oleg or anyone, or I thought it's an awesome presentation, by the way. I think we should really excerpt that presentation and put it up on our blog, by the way, along with the video, which we always put up from these sessions. That was just great.
I'm glad you found it useful.
Both in explaining the problems and why. I have got questions, but I want to let other people ask first.
Sure.
Okay, I've waited politely enough so I can ask that. Okay, so one question is, just so you say it, and I kind of want this almost so we can turn it into a blurb, but what is it that's attractive about Frictionless in, like, you know, for you? What was it that was, like, what's the attraction of it? What, you know, what is it, the spec? Is it the tooling? Is it some combination? What is it that's been useful to you, and why?
I mean, so practically speaking, the most useful thing for me at the moment has been the spec. Because it's, I mean, YAML or even JSON, it's not that hard to read, it's not that hard to generate. And as I mentioned, like, there are efforts in bioinformatics and genomics to solve some of these problems. People do try to create repositories of multiple data sets and do some things to normalize them, but I think they just don't go nearly far enough. And, like, the best examples I can find have very inconsistent metadata or no metadata at all.
Yeah.
And so my goal is, again, to, like, you know, I think a lot of them are probably held up by the fact that they're trying to do some things perfectly, which makes sense depending on your application. And my idea is just to, again, to do things pretty well or very well, good enough, but then really normalize things to a much higher level than what is currently done. So that way, the process of integrating data from all different sources becomes much simpler.
I got the goal, and what you're saying is you needed some lightweight spec that was human, kind of like, it's kind of machine generatable, it's lightweight, but it is well thought out.
Exactly, yeah. I mean, that's the important thing. So before I thought about Frictionless and Data Packager, really was aware of it. I mean, I started thinking about doing this on my own and just thinking about, okay, well, how do I describe data? Like, what is my data model that I'm internally thinking about? And I started to write that out, and then I kind of stopped and realized, you know what, like, other smarter people have already thought about this and tried to solve this problem. Like, let's see what's been done. And this was the best effort, and one that, I mean, really had thought about a lot of the same kinds of problems that I was thinking about, and come up with good solutions.
Yeah. Okay, that's really great. We should kind of turn that one into we can put it as a quote on the website. You know, I think I know Oleg's there. I don't know if he's got any questions. I think there's two things. So one question is, do you use Git and GitHub, and do you commit your data packages to GitHub?
So I have not done that yet. I use Git and GitHub, I mean, a lot, and I'm storing the code, or all the kind of pipeline code is version controlled. But I haven't been committing the data packages themselves yet. That's something that I definitely am thinking about also, like longer run, I need to have more redundancy in just terms of backups and things like that. Although data package Data Hub or Zenodo would obviously help with some of those issues.
Yeah,
but yeah, I think
doesn't version control in the same way. But okay, but you store the code that way. Because just for example, could you share your screen very quick, a slightly specific question? You showed like you had this like source kind of like list.
Yeah, so I can show you.
Yeah, could you show me that? And like, so why is that not a data package? Like what I'm trying to understand is why is that not that you should be like everything should be a data package, but why not? It looks kind of close to one, or is it? It's not quite, but maybe
so the idea, I'm kind of doing things in two steps, I guess. So I could write a pipeline. Can you all see my screen, by the way?
Yeah, we can see your screen, yeah.
Okay, great. So I could write a pipeline that tries to deal with each of these sources individually and kind of processes them into data packages. But they are ultimately different from one another. So this is one source, but there's some other ones, you know, in here.
Okay, but I got it. But you've got a whole bunch of your sources.
But there are a whole bunch of different ones. They're all kind of different. And so rather than write a pipeline that has to like deal with all these differences, my thought was I'll first have these little kind of recipes that wrap the data and get them to something close to normalized. And then in this packaging pipeline, I then just take the last step. And now, you know, using a very lightweight metadata that's enough to sufficiently describe how to go from those semi-clean data to a full data package.
Okay.
I can, at some point in the future, I could perhaps walk through exactly what that looks like from the kind of raw data source to the.
That would be, I think we're going to run out of time today, but I think it would actually.
Yeah, exactly. In the future, though, just let me know and I'm happy to make time for that. So I do keep track of versioning is also something that I think about a lot. So I have both a version of the pipeline, the packaging pipeline that I've written, and then also versions of the data from the data source. But this is also something that's a work in progress. And I mean,
I have a solution, just to be clear. So what I've been working, so Data Hub sort of had that, but so I kind of think the holy grail of that a little bit. I've had debates with lots of people over the years. So I am of the opinion that a very sweet spot, and which is where Data Hub right now is, just to say, kind of upcoming trailer for where Data Hub is about to be, is that basically you use Git and particularly GitHub, but you could use anything, GitLab, whatever, like, but use Git to store your metadata. Like you basically, if you think about it, you store your code and your data descriptor. So, and even your data file, like you store that all in GitHub. But what you want is you want the equivalent of Git LFS. You want someone to store your large data that is not Git, right? Because it's rubbish or like a gigabyte of like whatever you've got. But you don't necessarily want GitHub's LFS because it's slow and expensive or whatever. So what you want is to plug in your own, bring your cloud storage that you want, right? Okay. And that's actually not very hard to do with the way that Git LFS works. So over the last year, I've written a Git LFS. Other people had sort of thought of this idea before, but we've written a kind of pretty robust Git LFS server that you can plug in, you can plug into Azure, Google, S3, whatever storage you want, and just run on GitHub if you want, but with your storage as wherever the hell you like. Yeah, like you could just. So what you can then have is all of the Git attractions of like versioning your code, you version the data package, and the way Git LFS does is you version the files in your, they look like they're in your working copy, but they're not being stored in the Git tree. They're getting pushed out to the storage. And you can therefore, you have all of versioning, you have branching, you have everything you'd like around, that comes from Git that everyone's familiar with. You have the storage from cloud storage that everyone has. It has a lot of features that cloud storage, not only is it incredible bandwidth, but you have multi-part upload, resume on failure. I've even written an extension to Git LFS, by the way, or I shouldn't say my team has written an extension to Git LFS that allows you to do multi-part basically multi-part features, where you send chunks of the data and so on. And then what you want is you want a front end. Like the one annoying thing about GitHub, if you work with data, and it's a common one, like we've got a very popular COVID data set, which is GitHub's built for code. I mean, so for example, you go to a CSV file that's more than a megabyte and you can't preview it, or you can't do this, that, or the other. You see statistics like whether there's repositories in Python or R, but you don't see, here's the summary statistics of my data set. So what you want is a very kind of relatively lightweight portal front end that you can drop in and provides a browsable interface to your data. And that's the third piece of the puzzle there that you'd want.
So that's actually something that's probably the next step, the thing that I'm going to try to work on. Yeah. So I haven't decided. Oh yeah, go ahead. Sorry.
But so I'm just going to share very quickly, if I can, if I get to share. I think I am allowed to share that. And if I github.com/Datopian, for example, portal.js, and this is rough ready, but it is the third generation stuff. So the actual architecture is very polished. This is a kind of basically this is just a front. So this is I've taken CCAN, which is the old data management system that I don't know if you know, but we also were involved in building. It's like Zenodo or anything, but we've really we pulled CCAN apart into parts. So this is just, if you want to write just your front end. So you can then back it onto GitHub. You could back it onto any source of metadata, flat files on the hard disk, but it's just, it's written in JavaScript, in fact, in React and uses Next.js, but it's this kind of lightweight, you can kind of boot up your front end, customize it very quickly and deploy it, because what we see is often people want to write even micro front, I've got 50 data sets like this, and I just want to provide an interface that, they might be custom, it pulls out these metadata fields in this particular way because they're relevant to this community. You know what I mean? And yeah, anyway.
So that looks really great, and I'll definitely explore it and check it out. One quick comment, I don't know if you're actually parsing the CSV data on the fly, but you might consider if it's possible to support it using other formats. So I've done some benchmarking and I have some on GitHub I'm happy to share.
Where to store it? If you're storing stuff into the repo, or you mean using
so
things
just for so if you're trying to load data and do any kind of analysis on the fly, the time it takes to read a CSV file can be quite slow compared to other formats like Feather.
Yeah, compared to Parquet or something like that. Yeah. But totally. And I mean, the only thing is, so just to be clear, so totally in terms of you mean for data previewing and other kinds of functionality you want to put in, visualization.
Yeah, so I mean, I do a lot of stuff in Shiny at the moment, and I'll load data sets on the fly and, perform analyses and things like that. And if I try to keep everything in TSV or CSV, depending on the size of the data, it could be, 30 seconds just to read a file versus a second for a Feather file. So it really depends on the scale of the data, I suppose, and to an extent, probably also.
But to be clear, there's nothing in data packages or this that requires you to keep the data format and the data in CSV.
Okay, yeah, no, that makes sense. I just read CSV on the description, so I thought maybe it was somehow tied
in here. You mean in this one?
Yeah, exactly. In portal.js.
You guys, I'm gonna cut you off because we're at the hour. And I think everybody probably needs to leave. I want to give Oleg, see if he has 30 seconds that he wants to say hi. I know he has to go feed his kids though, so he might not be able to.
Hey, sorry for running on so long too.
Oh no, it's good. We just out of time. And Oleg, do you have a second to say hi or give an update?
Next time, nothing urgent except just really loving the conversation. Thank you also so much from my side. And, see you later.
Cool, thanks, Oleg.
Yasso, maybe just before you drop, Oleg, Yasso, do you want to just say hello and introduce yourself so the people here know you a little bit?
Yep, very quick. so I don't get everyone late to feed kids. I also have one, which is 12 years old. You probably listen to his noises while playing Minecraft when I'm in meetings. And I am doing a master's at Harvard. I've been working and following the open data scene in and out. I worked for W3C for a while, almost 5 years. I led a group of data on the web. But my alma mater is I am an industrial designer. And I think that's it. That's pretty much it.
Well, and just to say, yeah, so you've just part-time at least joined Datopian a little bit of time, and is going to be working with us on the Frictionless project. You know, we've been a little bit quiet the last 3 months at Datopian just because of the hiatus sometimes of client work, and also waiting for Yasso to join us. We're so privileged to have you on board, Yasso, and Yasadora. I know Yasadara, but Yasso is. So you did say you're probably going to be seeing Yasso on the channel and other stuff, and we're going to be moving things forward. You know, I really feel, just to end, I really am touched. I thank you everyone for your time and attention on the call. And I really feel the ground moving for us. Like I really feel that this space around the data stuff is coming to kind of a boil soon. And I think the material we have is as a community created, I think it's really gonna take off. And I think we're close. Like even what Evgeny's not here on the call, but the work on Frictionless Pi, we're gonna have a Frictionless JS ready to go pretty much soon. You know, like kind of core libraries and other stuff. I think, you know, I'm very excited about what's happening. So thank you.
Yeah, thank you. It was nice to meet you all.
Thank you. Thank you. It was nice meeting all of you.
See you next month.
Bye, everybody.
Bye-bye.
Bye, everybody.
Take care. Have a wonderful night.
You too.